Hello again. So we're going to move on to our new section, new chapter, exponential equations, and then that would lead into exponential functions. The quick review from previous grades, exponent laws, you need to know all of these inside out, very quickly be able to manipulate exponential expressions or equations using exponent laws. So I suggest you definitely go over the review video about the exponent laws that I have prior to this. Make sure you go through that, do some of those examples, make sure that you know what you're doing. And then we are going to move on to exponential equations. And the whole concept of exponential equations, what it means is that the exponent is the variable, and then using the exponent laws to manipulate and simplify the equation as needed and then solve for the equation. So here are some of the examples right here that I have put in there for exponential equations. Notice that every single one of them, you have the exponent, you have the variable in them, and sometimes they show up, like for example in the first example A, the exponent 2 to the x equal to 4. So what value is of x, you plug it in there, you get 4. So in this case it's very easy, you can just know that 2 is squared is 4. Great. But sometimes you may not be able to, so this is a little bit more trickier. All right, because you don't know what that is, and there is a process that I'm going to teach you, but that comes a little bit later on. But for the purpose of this section, exponential equations, we want to make sure that questions that they do show up, all the bases are the same. So what we want to do, for example, look at the example C. Even though we have 16 as one base, and then we have 2 is another base right there, right? And we have 8. These are all, they look very different, but actually we can manipulate all of these and put it into a very common base, and notice that all of them can be put in base 2, and that way once we have them instead of in base 2, then we can go ahead and solve. So let's start by looking at the process and do a few examples. So very basic example, let's start up with the 3 to the x equal to 9. Now most of you guys, or all of you guys, will know that 3 squared is 9. Fantastic. But I'd like to offer you another way of doing this so that it doesn't matter what kind of exponential equation you have, this process will work. So what you want to do, you want to leave every single term as the same base. So all the terms that you see, they should be showing up as the same base. So 9, I need to change that to base 3, and base 3, it's basically a prime base. That's what you want, prime number that is a base. So what is 9? Well, 9, I can write 9 as 3 squared. Great. Once you have a setup like that, then you know that this equation only works if the bases are the same. So we have the same bases, right? Therefore, if this equation is true, then we know for a fact that their exponent must be equal to each other. That's the only way this exponential equation, the left-hand side will be equal to the right-hand side. So based on that, then you can say, therefore, what we can say is that x must equals to 2, because that's the only way the left-hand side will be equal to the right-hand side. This process where you basically change all bases the same so that they are the same bases on the left-hand side and the right-hand side, and a single kind of expression on each side, okay? That way you just equate the exponents, and once you have them, then you solve for x, okay? And that process applies for any types. So let's go ahead and look at the second example. Okay, example B, which is basically the same question that I put up there as an example up there. Now we're going to go ahead and solve this, okay? So notice that all these bases are in different. They are showing up. This is 16, that's 2, and that is 8. They're not the same. But all of them, they can be written as base 2. All right, so that's where you need to start changing them. So for example, 16, just 16, can be written as 2 to the power of 4. And then I'm going to include the 2x on top. Great. Then the next piece, 2 is 2. That doesn't change. This 2 stays the same. So that's the same. That's 2. And the exponent stays the same. And the exponent is x plus 1. That equals 2. And then 8, you change that to base 2 to the power of 3. Bracket. And then the exponent is 3x minus 1. And notice that they're all in base 3. Base 2. They are all in base 2. Excellent. Now we have 2 separate ones that be multiplied on the left hand side, 2 separate bases or expressions, or right, that they're being multiplied. So you want to put them as 1. So let's do the math on that one. But before we do that, we need to kind of simplify it, because we have to use the exponent laws. So here, the first thing that you do, you have to take care of the 2 to the 4th times 2 to the x. So that would be 2 to the 8x. Remember, that's the power of the power. You have to multiply the exponents, and then 2 to the power of x plus 1. That's not going to do anything. I'm going to rewrite this as 2 to the 3 and 3 to the x minus 1. Good. Now we're going to look at this. Well, same base. What are we going to do with the exponents when we have a multiplication of the two expressions or powers? Well, here it is. We have to add the exponents. 8x plus x is 9x. And then plus 1. Remember, we are adding the exponent, right? That is, so this is the exponent addition. Very good. And then equals. Now on this side, we're going to do the power of the power. So that would be 9x minus 3. Remember that you have to multiply 3 into the bracket. Excellent. Now look what we have. We have 2 powers. That's a 1 power. That's another power. Bases are the same. Bases are the same. What can you say about the exponent? The exponent must be the same. So if this is true, we don't know if it's true. We're going to solve for all values of x that makes this equation true. Then this should be true, where the exponents, you set them equal to each other, and then you solve. And if there are any values of x, then that would be the answer. But in this case, you notice that that will tell you 1 is equal to -3. When you solve for x, the x's will go away. But this statement, it's not true. Obviously, because 1 is not equal to -3. So what can you say? Therefore, this equation has no solutions. Okay? So this equation that we brought up at the first, there are no values of x that will actually make that equation true. Okay? And that is the final thing that you have to do to double check, making sure everything is okay. And that is basically it. So look at this question. It's an exponential question, but as of now, you don't know how to solve this problem, because there is no way we can change the 3 to 4 or 4 to 3. We just don't know what to do with that. And they are not really in the factors of each other. We can't change 3 or 4 as a base of 3 or vice versa. For the purpose of this section, if a question like this shows up, you just have to do trial and error. Basically, that's what it will be, which is very inefficient. But later on, to a new concept called logarithms, then we can use that to solve exponential equations when they don't have any common or the same base. Okay?